Okay, hello, good morning, good afternoon, and good evening, everybody. My name is Jamie Lee Coleman, and today I am going to show you how you can quite easily take a MicroProfile and Jakarta EE application and get it running on Azure using the Open Liberty open source project. Right, so let's begin. So yeah, really, I just want to show you how simple and easy this is. This should take about half an hour. So by the time I've done my presentation, I will have been able to take a microprofile and Jakarta EE application. In the aspects of time, we're not going to go through designing that application, but we'll take you through basically taking that and deploying that onto the Azure cloud. So the technologies we're going to be talking about today is a fully open source stack, which is amazing. So it means you can try all this stuff and use all this stuff for free. So using Jakarta EE and MicroProfile as the specifications for creating the microservice we're going to use today. Open Liberty as the runtime, and this is all going to be running on the OpenJ9 JVM. Okay, so a little bit about Jakarta EE. If you haven't heard about it, Jakarta EE is essentially what Java EE has become. It's open source and it's community-driven specification for cloud-native enterprise Java. It's a set of specifications and it extends on Java SE for things such as web services and all kinds of different things like that. So these are the different strategic members. So thank you to all these people. Without them, Jakarta EE wouldn't be where it is today. And so Jakarta EE was kind of born in the second half of 2019 with an API which is identical to Java EE 8. Open Liberty was one of the first runtimes, if not the first runtime, to support Jakarta EE 8, and it's been the same for Jakarta EE 9. And the great thing is, using Open Liberty, it has kind of this zero migration policy, so you can transition from an older version to a newer version, say from Java EE 7 to Jakarta EE 8 or whatever, to Jakarta EE 9, and it shouldn't break any of your applications. That means you get to use all the nice new fun stuff. Eclipse MicroProfile. So these specifications, some of the ones we're using, they're shared between Eclipse at MicroProfile and Jakarta EE. But Eclipse MicroProfile kind of came around to solve a problem, which was to basically have an open source community driven specification for enterprise Java microservices. So a big community of contributors and organizations and individuals all kinds came together to drive this project, to create basically this specification that's really, really lightweight and has all the functionality and what we expect to create microservices in this day and age. So these are the different MicroProfile contributors, and without them, again, we wouldn't have MicroProfile, so thank you. And the great thing about MicroProfile is there's loads of different vendors. It's a vendor neutral thing. So you can use different runtimes with MicroProfile. You don't have to just use one. If you're using a runtime and the support costs are too high, you can then transition to a different one. It's completely up to you. So that's the great thing about it being vendor neutral. This is the MicroProfile 5.0 stack. So as you can see, some of these are shared with Jakarta EE, like I mentioned before, but there's loads of different specifications in there to help do different things. Obviously, REST, dependency injection, JSON-B and P for sending JSON between microservices, using REST. Things like fault tolerance, which are amazing. So being able to fall back and do different things if you can't talk to a different microservice. And then, of course, stuff to do with operations like open tracing, health checks, and metrics, and things like that. I must mention also, there are also these standalone projects. So if you want to, say, use a reactive architecture model with what you're doing, MicroProfile does support that as well. So the runtime we're going to be using today is Open Liberty. If you've not heard of Open Liberty before, this is an open source runtime created by IBM, really developed for developers and kind of this containerized cloud native world we're in today. So this is something called dev mode. So like I mentioned, developers are kind of at the forefront and the heart of designing and creating this project. And dev mode is really cool. It basically allows you to not have to worry about the runtime. You start up the runtime, and then you can make changes to your code, your test code, even the configuration of the runtime, and then you don't have to restart it. So those configuration changes, those code changes, and those test changes are instantly loaded into the runtime. For testing, obviously, you don't want to rerun your test every time you make a test change. So you just pretty much, if you've got OpenLiberty running in the console, just hit enter and it'll just spin your test up again. And this is great because it allows you as a developer to get on with coding and not have to worry about the runtime side of things. So yeah, all the main IDEs are supported. I think we were actually one of the first. So this is kind of based a little bit on Webs for Liberty, and I think Webs for Liberty was the first product in IBM to actually be containerized and be on Docker Hub, which is quite cool. But we're available on Docker Hub, different container repositories. Also, you can get the binaries from Maven Central. We support the main build tools, the latest APIs, so you can use OpenLiberty with Spring. And compared to, say, things like Tomcat, the throughput's nearly double what's using Spring on OpenLiberty, so it's a great choice there. And also supporting stuff like microshed testing or test containers to do your testing. So like I mentioned, this is all running on the OpenJ9 JVM. This was originally IBM's Java or IBM's JVM that our customers used. And this was open source to the Java community at the same time OpenLiberty was created. And this was one of the biggest open source contributions IBM had ever done in history. And this JVM is very, very robust, but it's also been kind of reconfigured for this cloud native world. So this is comparing the OpenJ9 JVM to Hotspot. And as you can see, the startup time is nearly half. It's got a much smaller footprint after startup. It's got really great ramp-up time, so if you've got to wait for your application startup or your JVM to load, etc., or to get to where it generally has the highest throughput, a lot of that time is wasted. So we want, like, really quick ramp-up time and also a smaller footprint during load, because all these things matter when we're running on the cloud and we're paying for resources. And lots of work have gone into OpenLiberty and some open source contributions into the OpenJ9 JVM, which has allowed this runtime running on this JVM to start up in about 1 second, which is pretty impressive. Bear in mind, this is a full-blown Jakarta EE runtime, supports everything. So you could run monoliths on this, you can all the way down to tiny little microservices. So it's really kind of a runtime that's built to support kind of everybody's needs. So the applications we're going to be using today are system and inventory. They're very simple microservices. The system microservice basically just returns the system property information for a specific host. So if we're running in containers, it'll be the system information for that container. If we're running on our local machine, it'll be the system properties for our local machine. And the inventory service basically just tracks the number of systems you have. And it invokes the system service to retrieve information about a system. So basically it just stores information about the different systems. So these are some of the specifications we're using today. So we're going to use health check, we're going to use config, and then we're going to use JAX-RS, CDI, JSON-P, JSON-B, and REST client from the MicroProfile and Jakarta EE specifications. So with that, I am going to now go and demonstrate how easy it is to get one of these applications, essentially spin up a Kubernetes cluster, spin up your own private container registry, and then deploy that application from your container registry onto the Microsoft Azure cloud. Okay, so let's get started. So first thing we want to do, we need to build our cluster. So when you're on this page, so you basically need to go to your Microsoft Azure portal, and then we're going to click Create New Resource. So if you type in here, Liberty, we can see the different options that are available on Azure. Now, you don't have to use these offerings. You can just stand up a Kubernetes cluster, and you can stand up a container registry yourself. But it's just better just to do this because this sets up all the components we need. So we're going to be just using IBM Webs for Liberty and OpenLiberty on Azure. If you want to go one step further, you can actually use the offering which will deploy OpenShift as well. So go click Create, nice and simple. Get started. So we need a namespace. So I'm going to create a new one. It basically allows you to easily delete all your resources afterwards. So we're going to call it Expert TV. Okay, so created that. I'm going to do it in my region, which is UK South, and this is just a manage user identity, just basically for billing purposes. Okay, so that's all done. I've got that, yeah. So now we need to create our cluster. I'm going to build the most basic cluster I can probably get away with. So this, I don't need 2 virtual CPUs and 7 gig of RAM for what I'm doing. So I'm going to go for something like this, which is two virtual CPUs and 4 gig of RAM. That's definitely a better size for what we need. Okay, so that's all done. Yep. So this option will create a new container registry, which we want. And do we want to deploy an application? No, we're going to take care of that ourselves. Then Azure will run its validation service just to make sure everything that we're trying to create here makes sense. And once that's all done, we can click create. So this will now go off and deploy our Kubernetes cluster. It will also go off and deploy, well, basically build a private container registry for us to use. Yeah, so we're all good. Right, so while that's doing that, let's go and get started. So we're going to be starting using this repo, which essentially has the microservices we built last time. So I'm just going to go and clone this down. So go and put this in a blank repo somewhere. I've got one here called Azure Demo, so just pop that in there. Okay, so we clone that down, and then we need to go into that repo and into the start directory. And this is basically where we have all the code we need to kind of get started with. So I'm just going to open VS Code, open whatever IDE you want here, just to get started. So the only prereq really you need for this is you need Docker, obviously, because we're building Docker images and containers, and you need the Azure command line. You also need kubectl, but you can install that using the Azure command line, which is quite cool. So let me just make sure our Azure command line is at the right version first. It should tell us our version now and basically set at the bottom say it's up to date, which it is. Awesome. Okay, cool. So now we need to log in. The Azure login is very, very easy. All you pretty much need to do is do that. It should open a browser window, which should authenticate, providing you're logged into your portal. And then, yeah, you should be all logged into the Azure, which is cool. Just let this get started. Okay, it's opened up over here. So you just pick your account. And then it should say you've successfully logged in. Please close this tab. And then we should see on here that it should say we've logged in. Awesome. Okay, so we're logged in. We've got our repo. We're in the right directory. Our cluster is deploying now, which is awesome. So if I go back to home, let's find the resource group I just created, Expert TV. So resource groups on Azure are basically a kind of way to, to group all your kind of resources together. And the reason I put it in a resource group, so after this demo, I can go and delete it afterwards. So that's all good. We'll leave that creating. So what do we need to do now? Now we need to log into the Azure container registry. So we need to first check that that's all come up and that's created. So we can click on our container registry here. Yeah, provision state succeeded. So it looks like we have our container registry all set up. Difference to last week was last week we used a public container registry. So anyone can use that and you can pull images from anywhere. Whereas this time we're going to be using essentially a private one, which we've created today. So we need the container registry name here. So we can just copy and paste it from our browser tab. And then this should now log into our container registry, and we should see that with the message login succeeded in a moment. Awesome. Okay, so let's package our application. I will go through the application in a moment for those who missed last week's episode. But first of all, I'm just going to get it all packaging. And when I'm doing the Docker build, that's when I'll quickly take you through the application code, because sometimes it takes a while. Okay. All right, so our applications are built, which package, which means basically all our source code is now in WAR files. What we're going to do is we're going to pull down the latest version of the Open Liberty image, which I presume I've already got, but we'll pull it down anyway, just to make sure. And then we'll go and build, essentially package our WAR files into our containers. So we need Docker build -t system 1.0-snapshot. So that's the first one, and we need to use the Docker file, which is in the system directory. That looks all good. Right, so while that's building, so in the system directory, we have a Docker file. Again, very basic. You don't technically need all the label things, but we're just pulling from the Open Liberty. We're copying in the configuration, which is in the config file, and then we're copying in the war. And the run configure.sh, this is the part of the Docker build which takes sometimes a little bit of time, but essentially it's a script inside the image. So when you're doing a build, it'll run that script to make sure it updates all your packages, etc., that are inside the image, just to avoid any security vulnerabilities. But it only runs when, again, we do the actual Docker build. When we deploy to production, this script doesn't get run. Okay, so while that's running, I'll just take you through. So system, again, just following on from what we did last time. We have our system resource system application, and this essentially kind of puts all our resources into kind of a common place. So it would be system, and then we have the actual resource itself. So this is the API we hit, and that's under the property path. It's request scope, so it's created on a request, and all it really does is it's a GET request. It produces the media type JSON in a response, and essentially it provides a response with, I know, the right OK. So it's a 200 response, which is what we want. So give that a second. It should be nearly finished now. So once that's done, we need to do pretty much the same thing for the inventory image. So we'll take that, essentially the Docker build will put that war into the container. So all we need to do is change, let's do inventory. And same down, yeah. Okay, cool. So yeah, once that's done, essentially we need to retag these. We need to retag them with the registry server, and then push them up to our registry, which is all good. So we've logged into our registry, which we did in a previous commands. That's all good. So let's go back here. So this is our login server. So it's essentially a combination of the registry name with .azure eco.io. So I'll copy that. Give this a moment to finish running the configure.sh script. So that, yeah, the inventory resource uses a lot of other things. It's a lot bigger application, hence why we haven't created it in one of these. But essentially, let's have a quick look. So this is the API. So here we're essentially doing a GET request to get the properties for a specific host, and then the path param is the host name. We take in that parameter and essentially do a query to get the right host back. Inventory manager pretty much essentially handles some of the storing and adding things. This again is like the other application we did before, so it kind of groups everything under this common path, and then we just have some more stuff around the system client used for doing client builder, etc. And then in the model, we basically handle some of the things for storing our properties. Okay, so let's go back here. Okay, we're all good here. Okay, so like I said, we do need to do Docker tag. We tag, say, system. Oh, let's do Docker images first to make sure they were built. Awesome. Okay, so as you can see, they were built 2 minutes ago, 35 seconds ago, so those are the right ones. So Docker tag, we're going to take do system first. Snapshot. Ooh, helps if I can type today. And we're going to tag that with, remember, it's this, which is the registry server. And then again, we want to take that and add that to the end. System 1.0 snapshot. Yep. Okay, so we're going to tag the first one. So, yep, now we just need to do the same for inventory. So we just quickly change these. And my hope in the background is our Kubernetes cluster is getting set up and it's ready to go. But we'll find out after we've done this. So right, so last time I checked, our container registry was up and deployed. So I should be able to just do a Docker push and deploy, push that up. Okay, awesome. While that's doing that, so the first image will take a while because the first time it's going to push all these layers up. And again, it's a private registry, so they will never have existed before. But the second push will be a lot quicker because, again, a lot of this stuff will exist. The only thing that I'll have to push up is essentially the layers with the application code in, and possibly some of the updates that are done by the configure.sh script. Okay, so while that's doing that, let's go back and check that our cluster has come up. Okay, so this is our cluster here. So according to this, it succeeded and it's running. Awesome. Okay. So there is a way we can easily check that. So when this is finished pushing, all we need to do is do a kubectl, get nodes, and if it returns a node and some information about a node, then essentially we know our service is running, our cluster is running, sorry. So yeah, we'll just give that a moment to finish pushing up. I apologize for my slow internet this evening. So I've been using just general Kubernetes at the moment. You can use operators, and one of the things that are provided with that Open Liberty and Webs for Liberty offering on Azure is the Open Liberty operator. I'm going to start, again, for the first 3 sessions of this series, I'm just going to be using general Kubernetes, because that's what most people use. But with OpenShift, we will be moving on to more advanced things like operators, and then I can show you kind of some of the benefits that operators will bring to you as an engineer. So give this a moment. Some big layers here. So just one more thing. I'll just quickly go back to here, close some of this stuff while we wait. So pretty simple. Again, very similar to what it looked like last week. The only difference is this image pull secret, and I will show you how to create that in a moment. But essentially, because this is not a public container registry, it's a private one. All private registries, by default, I think, all have security enabled. So you essentially need to get the password for that registry, put that into a Kubernetes secret, which then is used by the deployment here. As you can see, we've called it guide secret. And that will allow basically every time Kubernetes goes to fetch an image from our registry, it will use that password stored in that secret to pull that down and authenticate pretty much. Okay, it's nearly done. Just give it a moment. And so that's pretty much the only extra configuration I would say we have to do over what we do on the IBM cloud. Of course, you could set up your own container registry on the IBM cloud, but we just use the public default one for last time. Cool, my internet's going very slow this evening. Do apologize, give it a second. Like I said, the next image I push up should be very quick because all these layers should exist. The only layers that shouldn't is the application layer and possibly any discrepancies that were done between the configure.h scripts. So it looks like these are done now. So next step is to push up our other image, which is our inventory microservice. Good, that went well. Okay. Awesome. And again, the rest are all mounted because they existed already. So again, it's pretty much just pushing up our application code. Okay, so apparently we have our cluster. First thing we need to do is link our local kubectl command line to that cluster. So how do we do this? We do AZ, AKS, so Azure Kubernetes Service, get credentials, and then G. So now we need the group, which we called expert, what was it, TV. And then we need our cluster name. So we go back to here. This is our cluster name. I'll take that. So this should hopefully log me in to our, basically make my local command line connected to our one on the cloud. So if I do kubectl get nodes, hopefully our cluster is up and running. Yep, and our command line is pointing to the right place. Awesome. So we've got our cluster already. Now we need to do is go and create that Kubernetes secret to get the credentials for our container registry. So how do we do that? AZ, ACR, Azure Container Registry, credential. Then we do show-n. Then we need the registry name. Let me just quickly grab that. So there's our registry name. Then we need to query that. So -- query. We're going to be querying it for
passwords, and we're going to be looking for the first password that is stored, which should be the only password, and the value of that. And then put -o, TSV, enter, and hopefully our password will be displayed. Now, I wouldn't normally show you this if this was an important container registry, but it's something I've literally just stood up for this demo, so I will be shutting it down afterwards. So don't worry about my password being displayed because it will only exist while this demo is running. Okay, so that's all done. So now we need to do is create our secret. So kubectl create secret, and we're going to, it's a Docker registry. Remember, it's called guide secrets. It has to be called that. Well, it doesn't have to be that, but if we change this, remember we have to change what it's called in our kubernetes.yaml. Otherwise, yeah, it's got nowhere to get it from. Yep, so guide secret. Then we need to provide it with the server. So docker-server equals, again, the server is this one, the login server here. Okay, then we need Docker username. This is just the name of the registry, so it's just that. Cool, and then we need Docker password. The password is the password we have from the previous command, so just copy that. And then finally, Docker, I don't know actually if this one's required, but basically I just put the email address I use for dockerhub.ibm.com. Okay. All right, so I've created that secret. We'll find out if that secret's right or we've done something wrong there. Docker username, Docker password, Docker server, guide secret. I think it's all good, but we'll know because basically when we try and do our deployment, none of our images will actually deploy, which is not good. Okay, so let's have a look at Kubernetes YAML. So what do we need in here? We need our registry server. So this is basically telling Kubernetes where to go and get our image from that we're trying to deploy. So that is here again. So we just copy that, replace that in our YAML. I do apologize for any banging or fireworks. It's Diwali today, so a lot of people are celebrating outside. Okay, that should be all good. Right, so now we can do our deployment. So kubectl create -f. Make sure you're in the start directory because that's where our Kubernetes YAML lives. Kube.yaml. All right, so we'll go do that. We'll create that. Now, if we do kubectl get pods, hopefully we should see it starting to deploy our pods. So like I mentioned, you do get the OpenLiberty operator with this offering, which you can use. We're not using it today, but just future reference, it's quite good to deploy OpenLiberty using the operator. And the operator extracts away from some of these levels just to make your life a bit easier. Okay, so it should take, I think the first time I started this up, it took about 30-40 seconds for the pods to get ready. Now, for some reason, I don't know why, it takes a lot longer on Azure than it did on the IBM cloud. But if I delete the deployment and restart it again, it comes up in like 2 seconds, which I was a bit intrigued about. I presume the container and the image must be living on the same machine where Kubernetes is, so it's probably deploying a lot quicker. Okay, so everything's all up and running. So we've essentially taken our Jakarta EE and MicroProfile application that we built last week, that we deployed on the IBM cloud, and we've done pretty much very similar thing and deployed it to Azure. So let's try and access that. I'm not going to have you all take my word for it that this is running in the Azure cloud. So let's do kubectl. First of all, we need to do is get the service, and we want the system service. So this will get us information about that. As you can see, we have our cluster IP here. So let's take that. Let's open up a new thing. So now we should just be able to put 9080/system/properties, and ta-da! Our application is now running in the Azure cloud on an offering we just set up. And in the we've done all this while this demo's been active. So there was nothing I pre-prepared for this. Other than downloading the Azure command line. So that's all good. So now let's access our other service, which is the inventory. Of course, they've got different IP addresses, so let's access this one. I think this one is 9081. We'll just delete that. 9081, and it's inventory/systems. So this shouldn't show anything because we haven't actually invoked the inventory system service and nothing's been stored in there. So let's go and do that. So we want to basically add to our list our other service, the system service. We can find the IP of that here, like we found before. So I'll copy that, add that here. And then this will then go and invoke that and store that into our list. So that should be stored. So if I remove this now, go back here, there is our other microservice that's running on our cluster in the cloud, which is quite neat. So one last thing really before I kind of wrap up, let's just test this. Again, kind of like last week, we just need to provide some certain things where it's running. So just Maven, we're going to use the fail safe integration test, test plugin, basically. And basically all you need is, we're going to provide it some variables. So the system.ip, which is equal to that one. Yeah. And then all we need to add is the inventory IP, which is equal to this one. And if the demo gods are kind, we will run all our tests, and they, rather than running locally against our local deployment, they're all going to be running against our containers all running in the cloud on Azure. First test passed. Yep. Awesome. They've all passed. Wicked. So yeah, that's pretty much it. Remember to go and delete your deployment afterwards. So if you're in the same directory, you can just do kubectl delete -f and then kubernetes.yaml. The process will sit here and hang, because what it's going to do is keep checking to make sure all the different resources that were created via this deployment are being deleted first before the process ends. So basically, when I get control of my terminal again, everything's been deleted and yeah, cleared up. The one last thing I would recommend doing is going into to your Azure accounts, go to your resource group, whichever what it was called, and delete it. Because basically what that will do is delete all the resources underneath it. Now, before I do that, I'm just going to wait for this process to finish, because I don't want to start deleting my cluster and everything while it's in the middle of doing stuff. Technically, that should be fine, but I won't risk it. Okay, well, while that's doing that, again, all you need to do, delete resource group, and it'll clear up all the resources that were created for you, which is quite nice. Okay, so finally, let me just wrap up here. So again, today we've been using a fully open source stack. So MicroProfile, again, all open source, loads of cloud-ready APIs that were built for microservices, and it's got a big community that's growing constantly. Open Liberty was the runtime we used, which was built for cloud-native architecture. So all microservices, spanning all the way up to, you can use it for monoliths if you want. But it's great for microservices with its fast startup time, it's lightweight, and it's really easy to configure. Jakarta EE is really the backbone of all this. It's open source, like I mentioned, really built for enterprise Java APIs, but for cloud native architecture. There's no vendor lock-in, so you can go to loads of people, and it's got a massive community. Of course, you've got the existing Java EE community on top of all this new community that's come to life because it's now open source. And of course, all built and running on top of the OpenJ9 JVM, which was really built and designed to be a cloud-native JVM. There's lots of different links here to get started. I mentioned last week again some of them. I've added in this week the Open Liberty Starter, and that's really great because it basically takes you to a web page which provides everything you need to kind of get started with cloud-native applications. And yeah, I just wanted to end by saying thank you, everybody. Tune in, not next week, the week after, where I will be doing something very similar with AWS. And then finally, we'll move on to OpenShift and operators for the final session. So I hope you all enjoyed my session today, and yeah, happy programming. Thanks.